Hello and welcome to your new booklet. We're going to be talking about sound. So we know that sound is a type of energy because we've done all of our energies before. And so we're going to look at how sound moves and what exactly is sound. So we know that there are particles in everything. So air is made up of particles, the desk's made out of particles, water is made out of particles. Okay, so sound uses those particles to travel. So say we've got some particles in air, all lined up like that. What happens with sound? Sound is a vibration. So sound vibrates the particles. So if you make a sound, say your voice box starts vibrating, and then it starts vibrating the particles next to the voice box, and they start vibrating. So that's my sort of vibrating action there. And then they pass on that energy, that vibration, to the next particle next to it, and then that passes on to that one. So it's a bit like a Mexican wave, and they pass on that energy, keeps going, until eventually it arrives somewhere. So it could be your ear. I'm not very good at drawing ears as evidence there. And then it starts vibrating the little bones in your ear, and then you can hear sounds. And that's basically what a sound is. And the fancy word for that is called a longitudinal wave. Okay, longitudinal wave. And that means that it's passing on energy along a row like that. So it passes on the vibrations. Okay, so let's start the booklet. And there we go. So, introduction. We know that sound is a form of energy because we've done the energy before. And all energy is transferred by waves. So sound is transferred by a sound wave or sound waves. And a sound wave is an example of a longitudinal wave. That's what I was just talking about. It's passing on the energy along a row. So, following demonstration will help us to understand what sound waves actually are and how they travel through medium. So what I've attached to this is in this blog post. There's a video straight after this, and it's a video of this demonstration. So what the demonstration is a signal generator. So that creates sound, okay, and it's connected to a loudspeaker, which can then project the sound. And that loudspeaker vibrates. Loudspeakers vibrate back and forth. That's how they work. When they then vibrate the air particles next to them, which then vibrates another air particle next to it. And what we have is a candle set up. Okay, so those air particles next to the candles start vibrating. So what happens to the candle? The candle starts vibrating as well. The flame starts vibrating sort of the same rate, the same vibration as the loudspeaker. The candle is lit and the signal generator is then set so that a very low-pitched note is produced by the loudspeaker when it's switched on. The low-pitched setting on the signal generator causes the corner of the loudspeaker to move back and forwards a small number of times each second. What happens to the candle flame? Well, as you'll see when you look at the video, the candle flame starts vibrating back and forth. Starts vibrating back and forth. And it actually starts vibrating at the same time as this loudspeaker you'll see in the video. And it's really cool. If you turn the loudspeaker up enough, so it's got enough energy, sometimes the loudspeaker can actually blow out the candle because it moves so violently. Okay. So the candle flame behaves as it does because the forward movement of the loudspeaker cone pushes some of the air particles between the loudspeaker and the flame closer together. In fact, the vibrations cause some particles to squash together and some to spread apart. So you can remember when I said this is another demonstration of basically drawing lots of particles. Okay, if that particle moves that way, but that one's also moving that way when it's vibrating, they become closer together, but then this one moves further apart. So you get areas of very densely packed particles and you get areas that are less densely packed particles. And this is lots and lots of particles here. Lots of those particles all together. And you can see there are areas where they're a bit more spread out and here where they're a bit more closely packed together. Okay, and that's a longitudinal wave. And as I said, all sound energy is produced by those vibrations of those particles. And the number of vibrations produced per second is called the frequency of the sound. So that's a really good physicsy word. Okay, and it's measured in units called hertz. And tuning forks are used to produce a pure note, a sound with only one frequency, so they only vibrate a certain amount of times per second, and that produces a lovely one note. And quite often, those of you that are musicians, you might use tuning forks to tune up your musical instrument because it gives you one note. Okay, And that note, the frequency is another word for pitch. So for those of you that are musically inclined, you'll know that pitch is how high or low something is. So the amount of times it vibrates depends on how high pitched or how low pitched something is. Again, I'll attach after this a video of a tuning fork. It's quite cool to see them move in slow motion. You can see them vibrating back and forth. So the higher the frequency, the higher the pitch of the sound we hear. And sounds of a range of frequencies can be produced in a lab with that signal generator and a loudspeaker. And what I'm going to do again is I'm going to attach another video, so you're going to have 3 videos to watch after this, to show you the range of human hearing. So technically humans can hear between 20 hertz, which is quite a low frequency, and 20,000 hertz. Okay, so there's quite a range of vibrations that humans can pick up with our ears. Some humans can pick up more than others. You guys are younger than me, so you'll be able to hear a wider range of frequencies than me. As you get older, you tend to be able to hear fewer frequencies, so you can't hear quite at the edges. So I'd be quite interested to see how much of that frequency you can hear. And obviously, animals like dogs can hear much higher frequencies than we can. And the material through which a wave travels is known as its medium. We're normally used to sound travelling through air, but it can also travel through other things. So it can travel through water, it can travel through solids as well. So sound waves, but they have to have a medium to travel through. Sound waves can travel through solids, liquids and gases, but they do not travel through empty space. So, have a look at this. Fill in the gaps. So sound is a form of energy. And the energy is transferred by waves. And sound is this is that fancy word again, longitudinal wave. Sound energy is produced by vibrations. And usually we hear sounds because of the vibrations in air or particles, so the gases. But it can also travel through solids and liquids. Pen doesn't like me today. Sound waves need a medium to travel through, so they have to travel through something. And sound cannot travel through what we call a vacuum, because a vacuum is basically nothing. A vacuum contains no particles to vibrate. We know that sound travels because of those vibrating particles. So a vacuum doesn't have any particles, so sound cannot travel through a vacuum. I'm going to pause there, and I'm going to let you watch the videos that I've just talked about, and then we'll continue with this once you've watched the videos.